Hello, namaste, dear all. I'm Mangal Vijachai. Today I have number one video of differential calculus with the topic relating to the tangent and normal. And here's the question: find the condition that the line x cos theta plus y sin theta equal to p is normal to the ellipse x square upon a square plus y square upon b square equal to 1, and related diagram I have drawn over here. So there's one ellipse, and there's a tangent at point sk on the ellipse, and at the same point sk there is a normal. I have drawn with the green line. Tangent I have drawn with the red line, and there is a ellipse. Now let the given line and ellipse be denoted first by equation 1 and 2. Let x cos theta plus y sin theta equal to p be denoted by equation first, and x square upon a square plus y square upon b square equal to 1 be denoted by equation 2. So these be the equations of given line and ellipse respectively. Okay, now what will I do over here is we suppose this equation first will be normal at the given ellipse at the point h comma k. So let's do that. Let equation 1 is normal at equation 2 at the point sk. Here sk is the arbitrary point, any point could be taken. So line given line x cos theta plus y sin theta equal to p will be normal at x square upon a square plus y square upon b square equal to 1 at point sk we have supposed. Then we try to find equation of the normal on the given ellipse at the point hk. So for that we have to find the slope of tangent and normal, and for that we will be doing differentiation with respect to x in the equation 2. Differentiating equation 2 with respect to x. So 1 by a square I'm keeping outside, so derivative of x square respect of x. 1 by b square I'm keeping outside, so derivative of y square respect of x, and derivative of 1, that is constant, so derivative for constant is 0. Or we get here 1 by a square, for x square's derivative is 2x. 1 by b square, and derivative of y square respect to x 1b. We have to form chain over here, so derivative of y square respect of y into dy by dx. Then we get here 2x by a square plus 1 by b square, and derivative of y square respect of y is 2y into dy by dx. Or so 2y by b square into dy by dx equal to minus 2x by a square. Now we can find dy by dx. So minus 2x by a square is there on the right side, and let's send 2y by b square to the right side. So b square will go for multiplying and 2x will come for dividing. Then we get here dy by dx equal to some mistake I have done over here. Okay, 2y by b square by 2y should be here. So b square by twice y is here. So 2 will get cancelled, and then there will be remain minus b square by a square into x divided by y. So this is the slope of the tangent. Therefore, slope of tangent at point HK is equal to minus b square by a square. So at HK, x we have to keep h, and in place of y we have to keep k. So slope of tangent is found, and we need to go for finding condition of the normal. That is why we have to find the slope of normal as well, and the relation is product of the slope of normal and tangent is equal to -1. Then slope of tangent into slope of normal equal to -1. So we have found here a slope of tangent minus b square upon a square into h by k. Let's skip this, and through this we get the slope of the normal. So on either side minus will get cancelled, therefore slope of normal, this will be equal to, so divisor a square and k will go for multiplying with 1, and b square and h will come for dividing. So b square a square into k by b square h we get as a slope of the normal. And once we find the slope of normal, now we can identify the equation of the normal as well at the point hk. Then equation of normal at point hk is y minus y1, y1 that is k, and slope is here a square k by b square h, and x minus x1 is h. Now let's go for cross multiplying. So y times b square h minus b square hk, and equal to a square x a square k minus a square hk. Now let's bring x and y on same side. So x a square k I'm keeping on same side, right side, and I'm bringing y b square from left to the right. So minus y b square h, and let's keep constant terms together. A square hk I will bring to the left side from right, so we get here a square hk, and b square hk is already over there on the left, so I'll copy same thing, and then hk will be common. A square minus b square will be inside of the bracket, and here it is same, x a square k minus y b square h. So this is the equation of the normal, is the okay, and let this be denoted by up to number 2 we have denoted. So let this denoted by equation 3 is the equation of the normal at point hk on the ellipse x square upon a square plus y square upon b square equal to 1. So equation of normal we have found like this, and we have already noted equation of the normal as x cos theta plus y sin theta equal to p, because this is about to be the normal on the ellipse. So equation 1 and equation 2 are this last one 3 are identical. Then as equation 1 is normal on the ellipse, this is the thing which we have to find. That is why you can say 1 and 3 are identical. 1 and equation 1 and equation 3 are identical, and as they are identical, their coefficients should be in same proportion. So here for the 3, coefficient of x is a square k, and for the first one, coefficient of x is cos. So we can take their proportion. Therefore a square k upon cos theta, and this will be equal to coefficient of y is here, I'll mark by coloring over here. Here in the third equation, coefficient of y is minus b square by h, and in the first equation, coefficient of the y is sin theta. So this would be in the same proportion. So you can write over here minus b square h upon sin theta, and this is equal to now coefficient constants. So constants are, in the third equation there is hk a square minus b square, so hk a square minus b square, and constant is there p in the first equation. So here's p. Okay, so this coefficient, ratio of these coefficients will be also equal, or ratio of constants will be also equal. So it's a square minus b square divided by p. Now let's find, by using these three ratios, now let's find the values of h and k. So let's take first and third. Taking first and third ratio. So first and third, if we take a square k by cos theta, this is equal to hk a square minus b square by p. Now what happens? K and k will get cancelled, so there remains, or we write a square upon cos theta equal to s times a square minus b square divided by p. So through this, what we get here, h equal to a square p divided by cos theta into a square minus b square, isn't? P and a square will get multiplied, and a square minus b square will come down for multiplying with cos theta. So if we want to bring this cos theta up, then it will be 1 by cos equal to sec. So a square p sec theta divided by a square minus b square we can write. So therefore we get value of h equal to a square p sec theta divided by a square minus b square. So value of h has been obtained, and now here we took first and third. Now let's take second and third for finding the value of k. So second and third, let's write taking second and third. Taking second and third ratio. Actually I should have written here first and third in war, but I have written like that way over there. So second and third, minus b square is by sine square, minus b square is by sine theta, and on the right side sk a square minus b square by p. Sk a square minus b square is k a square minus b square to p. Okay, so here on either side h will get cancelled. I'll show you by cancellating also. So h here will get cancelled. So there remains minus b square by sine theta equal to k by a square minus b square times p. Now let's find here k. So it will be here k. A square minus b square, p will multiply with b square. So minus b square p, a square minus b square you could write, and down is there sine theta only. Therefore value of k is, let's bring sine theta above and let's write cosec theta. So minus cosec theta, b square p, and a square minus b square. Okay, let's check we've got correctly over here. Not somewhere I have made mistake, I guess. Okay, so here h was a square p square by, okay, so a square into p and cos theta into a square minus b square, that was right. And at the down, what I write over here, hk a square minus b square by hk square minus, oh yeah, so a square minus b square was above, I wrote down over here. So let's make correct it. Okay, a square minus b square is not down here. Okay, so here a square minus b square is above, it's k square minus b square by p. So h is got on either side, and k times a square minus b square divided by p. So this way we get here k equal to p into b square minus p into b square, and sine theta is already there, and a square minus b square will come down. This square. So sine theta kept sent above, so became cosec theta. So k is minus cosec theta b square p, and a square minus b square is down. A square minus b square. So values of h and k both we have now found. Value of h is found a square p times sec theta by a square minus b square, and value of k is found minus cosec theta times b square p divided by a square minus b square. Now after finding value of value of h and k, values of h and k after found, we keep these values in the equation of the ellipse, that is h square upon a square, k square upon a square plus sorry, h square upon a square plus k square upon b square equal to 1. So that was the equation 2, isn't it? So in 2, let's keep the value of x and y. So let's keep over here. As ellipse passes through s comma k, so you can put the value of hk in the equation of ellipse. Putting value of h and k in the equation of ellipse. So doing that, what you get here, h is here a square p sec theta a square minus b square. So a square b sec theta, a square minus b square, this is the value of h square upon a square, and plus value of k, let's keep minus cosec theta b square p divided by a square minus b square whole square upon b square and equal to 1. So we have kept the value of h and k in the equation of the ellipse. Now what comes, let's see. Or a square square a power 4 p square and 6 square theta divided by a square minus b square whole square, and a square is down, so let's keep same over here. Minus square, it removes, will be plus, and cosec theta square, so it is cosec square theta b square square b power 4 p square and divided by a square minus b square whole square, and down there is b square, so let's keep same. And after that, then we can cancel a power 4 and a square over here. Okay, I'll show you. A power 4 and this a square could be cancelled, and will result a square only, and on another term, second term, b power 4 and b square could be cancelled, and by cancelling there will be remaining b square only. Okay, let's write over here down. Okay, so a square p square 6 square theta is remain in numerator, and down there is a square minus b square whole square, and plus, so cosec square theta b power 4 divided by b square, that is b square into b square divided by a square minus b square whole square and equal to 1. And from here, what do you get next? See, LCM of the denominator same over there, so a square minus b square whole square and a square b square 6 square theta plus cosec square theta b square and b square, that is equal to 1. And in numerator, b square can be taken common, so taken common, a square 6 square theta plus b square cosec square theta and equal to this denominator a square minus b square whole square, I multiply with 1, so will be a square minus b square whole square on the right side, and then let's bring it down. So p square equal to a square minus b square whole divided by a square 6 square theta plus b square cosec square theta. So we get, therefore, p equal to a square minus b square. I'm making square root on both sides, so square is removed, a square minus b square only remained, and there is root under a square 6 square theta plus b square cosec square theta. So this is the value of p, or condition of the tangent, condition of the line x cos theta plus y sin theta equal to p for being normal on the ellipse having equation x square upon a square plus y square upon b square equal to 1. I hope most of you who are watching and who are related with this thing got very clear idea of this thing. Thank you for watching, everyone, and if you liked, please don't forget to share and like and support me. Thank you everyone.